So I'd like to welcome Satoshi Tanda back to REcon, returning after, I think, 5 years. So he's going to talk about HyperPlatform. Thanks.
Yep, welcome to my talk. So before I start the talk, let me add one funny personal story. So this is a picture I took 5 years ago when I came here for REcon for the first time. But this picture is not actually a picture in Montreal. This is a picture in Chicago. When I was heading to Montreal from Japan, I had to transfer my plane at the Chicago airport. And I was ready for this, but my flight delayed, and I had to go to a different boarding gate from the one I originally had to go. And that was also my first time to visit a different country and even take a plane. So I got confused and got lost in the airport and missed the flight and ended up with staying at a hotel in the nearby the Chicago airport. That was a funny memory to me. And now, I'm pleased to be here without getting lost. I didn't go to REcon.com. I managed to be here. So I am going to talk about open source hypervisor project named HyperPlatform. So if you are interested in Windows kernel, hypervisor, system monitoring, or some sort, you will be interested in. So in this talk, I am going to tell just a couple of things. So if you want to have more ability to monitor and control Windows system activities in a lightweight manner, HyperPlatform is for you. And HyperPlatform is a hypervisor designed as a VM exit filtering platform to utilize virtualization technology and write new types of monitoring tools on Windows easier and quicker. So that is basically what I am going to tell in this talk. So let me introduce myself quickly. I am Satoshi, and a reverse engineer interested in Windows kernel, and I implemented HyperPlatform. And I am working at Sophos as a threat researcher, specializing in behavior-based malware detection. But this project is entirely done independently, so feel free to reach out to me directly. And Igor, he is a co-researcher, and he is an independent researcher specializing in cybersecurity, especially memory forensic and rootkit analysis. Unfortunately, he is unable to come here, but you can definitely reach out to him as well as me. So let me start with motivation. Why do you need yet another hypervisor project? So a few months ago, we had issues. We found that we still didn't have a good tool to analyze Windows kernel activities. So in my case, I personally wanted to analyze PatchGuard, so not by my employer. I personally wanted to analyze PatchGuard. And PatchGuard was a challenging component to reverse engineer because it doesn't allow you to modify Windows kernel in any way. So you can set neither breakpoint or hook to monitor its activity. And Igor, he also wanted to have a new tool to analyze Windows kernel because he constantly dealt with rootkit for his research. Debugger and IDA is always works, but it is always also time-consuming. So those tools weren't quite efficient. But actually, a lack of tool wasn't a real issue because we kind of knew a solution to it. The solution was virtualization technology. So there are plenty of academic paper and analysis systems using virtualization technology. And also we knew that virtualization technology is just more than providing sandbox environment. So a lack of tool wasn't a real issue. The real issue was that there was no suitable hypervisor to utilize virtualization technology only for system monitoring purpose on Windows. So assume that you want to monitor a system by using virtualization technology on Windows. You need a hypervisor. But what options do we have? Like first off, there were a couple of good-looking commercial products, but obviously those were proprietary and not available to us. And if you take a look at some existing lightweight hypervisors on Windows, those lacked modern platform support. For example, like HyperDebug, which is a really awesome project, but it didn't support 64-bit architecture. And if you take a look at more comprehensive hypervisor projects, those were just too large to understand and extend. If you are hired for this, you will probably be okay. But if you want to independently do some research, it's probably too time-consuming. And also, those projects weren't quite Windows engineers friendly. It requires, say, Sigwin to install and compile first. We found that Box was actually a kind of exception. We found that Box was quite easy to compile and run and even understand, but that was just too slow for day-to-day usage. So to summarize, this is our list of challenges we believe that we should tackle, and we believe that a community needed a solution to it somehow. So we decided to work on these problems. And as a solution, we developed a HyperPlatform. HyperPlatform allows you to monitor Windows system activities, including kernel, and it is open source and supports Windows 7 to 10 on both 64 and 32-bit architectures. And it is small enough. And one of the nicest things of this project is that you can compile this project on Visual Studio without any third-party libraries, and it can be debugged just as a software driver. And it is fast. And this is how does HyperPlatform work? So if you are familiar with Blue Pill hypervisor, this is essentially quite similar. So first off, it is loaded into kernel address space as a software driver. And then it enables the VMX operation mode of the processors. And once the VM-exit operation mode is enabled, processors start to treat the entire system as a virtual machine and invoke a registered handler routine upon occurrence of certain events, such as exception or execution of certain type of instructions, or access to system registers like control register 3. And those events are called VM-exit, and HyperPlatform implements the handler. So VM-exit handler in this example. And to get a rough idea of how event handling works, this is pseudocode for VM-exit handler. So when a VM-exit happened, processor invokes this handler directory and also gives a context of the system, namely values of registers, and also a reason why VM-exit happened. And according with this reason, handler execute real implementation of handler, so for each event. And you can extend the handler for your own purpose if you want. And you can understand HyperPlatform as a VM-exit filtering platform. And on the top of the HyperPlatform, you can write extended logic only for events you are interested in. For example, move to control register 3 event. And you can forget about all other events you are not interested in. And this is essentially how HyperPlatform is used. Then, what is an advantage of using HyperPlatform, and why do you want to use it? A short answer is, you can do what you cannot do without virtualization technology. So firstly, like VM exit is a new class of events you can filter. So with HyperPlatform, you can tell occurrence of a processor-level event, and even just an access to memory if you configure extended page tables. And secondly, the VM exit handler is quite flexible. So you can return a different register value against, say, read MSR instruction. And also you can return a different memory contents against read memory operation in a system. And importantly, none of them is easy to implement without virtualization technology. But with VT, it is quite straightforward. By utilizing those capabilities, you can implement meaningful logic for your own purpose on the top of HyperPlatform. So let me share some ideas and example application implemented on the top of HyperPlatform. So primary application I can think is kernel code analysis. For example, like detection of dodgy instruction execution. For instance, malware rootkit often modifies a value of control register 0 to disable memory write protection. But this is quite uncommon on normal system execution. So you can detect that event with VT, and then you can make a further investigation. And the other application is detection of pull execution. So by using EPT, you can catch execution of memory, and then you can check whether the address being executed is backed by any image or just a heap. In kernel, it's called pull. And if it is just backed by pull, it is quite suspicious. So you can also make further investigation against this region. And with this technique, you can get unpacked rootkit code from the memory pretty quickly. So I will demonstrate it shortly. And as more advanced application of EPT, you can implement invisible API hook. If you are interested in this project, please check out GitHub page, so DDI-mom. Okay, so let me demonstrate memory mom, which is able to detect execution of pull with a robot driver. So in this demo, I am okay. All right. So let's run 64-bit Windows 7. So in this demo, I am going to run malware, which is packed. And then I will get unpacked code extracted onto memory using memory mom, which uses EPT. So this is a driver file, malware rootkit file. And this is a corresponding IDA file. And if you take a look at a list of string, you can see that like list is pretty short, and yeah, so most of the contents in a file is just a data. So those are quite strong sign of packed file. And then let's load memory mon. Memory mon usually doesn't show much logs because execution of memory is quite uncommon on normal system. But if you run this malware, oops. So memory mon started to show a lot of logs. So each log represents execution of memory outside of any driver file. Yeah, so let's take a look at this entry. So this entry indicates that somebody executed this address, and it is not backed by a driver file. It is just a pool. So let's take a look at the contents with the local kernel debugger. Now, so the contents, oops. The contents looks like an entry point of function on a heap. It is quite suspicious. So let's take a dump of this region. So this address and wrapping to page boundary and little bit backward and take 1 megabyte. So that's extracted data memory contents dumped to a file. And if you give it to either and loading it to a right place, and if you take a look at the address, executed address, you can see a nice structure of function. And also, if you take a look at a list of strings in this memory region, you can see many interesting strings, like beep.chess, cpip.chess, probably TCP/IP, or a proxy.chess, or some function names, or API names. And we didn't see those strings in a static file, so it is likely that this content is unpacked rootkit code extracted onto memory. So you can use this you can write this kind of tool to assist your reverse engineering work using HyperPlatform. Yeah, so apart from code analysis, you can implement hypervisor-based protection if you are interested in. So by terminating a process instead of just monitoring. So EOPmon is a such example. So EOPmon can detect a successful exploitation of privilege escalation vulnerability by checking a token field of a process structure in a kernel. And EOPmon performs a token field check when a process that is currently executed on the processor is changed. So when a current process is being updated, Windows also updates a value of control register 3. And because control register 3 is a system register, it triggers VM-exit. And then EOP-MOM performs, it checks a process that is ending its execution. And system repeats this cycle for each process. And whenever EOP-MOM detects token stealing, so successful privilege escalation, it terminates the process. And in case of EOP-MOM, it is like VM-exit is just a trigger point to perform scan. So EOP-MOM doesn't even use a value of control register 3. It's just a handy timer event kind of thing. So let me quickly demonstrate EOP-MOM with a real malware. So I am going to run Gozi sample, which exploits a local kernel privilege escalation vulnerability. Right. Yeah, so this is 32-bit Windows 7. And first, I am going to run malware without EOP-MOM and show successful exploitation first. Now we have a command prompt running with low integrity. So if you start any process from this command prompt, sub-process is going to be also a low integrity. But this malware this one. So this guy exploits a system vulnerability and gets system privilege first, then spawns system privilege explorer.exe. So that is how this malware works. And then let's run the same sample with EOP-MOM. So EOP-MOM is also implemented on the top of a HyperPlatform. And run the same malware and see if it is going to be detected. So now I executed malware, the same sample, PID 1864. And then it starts exploitation, hopefully to protect the system. Now it couldn't, like malware couldn't spawn explorer.exe because like EOP-MOM detected an exploitation and terminated the process before the malware does really bad things. So you can write this kind of like protection or tools by using HyperPlatform. Okay, so yeah, so let me briefly touch up on some limitations on this project. So first of all, it cannot run inside VirtualBox because VirtualBox doesn't support nested virtualization. So you cannot simply run, like you cannot run this project inside VirtualBox. And also it doesn't support AMD processors. And thirdly, it cannot run with other hypervisors on the same box simultaneously. I am trying to find the time to fix this issue, but at this time, it is a limitation. So you can run like HyperPlatform and VirtualBox VMware at the same time in the same box. And as for the future of this project, I hope to see more use of this project from a community in any ways. And so I am looking forward to hearing more feedback and ideas on what you can do with HyperPlatform. I have some idea though. So for example, probably we can write kernel code coverage monitor for effective fudging with using Intel processor trace. Or we can write memory access visualization or authorization. Actually, Igor is working on this project at this time, at this moment. And also, probably we can use HyperPlatform for bug discovery, especially race condition type of bugs, by analyzing memory access pattern with extended page table. But those are all yet to be planned. So I am looking forward to hearing more feedback and comments on this project. So let me wrap up the talk. So virtualization technology is a powerful but still underutilized technology for reverse engineering. And HyperPlatform is a hypervisor designed as a VM exit filtering platform. And yeah, you can utilize virtualization technology and write new types of tools on Windows quickly and easily. And yeah, if you're interested in, please check out GitHub webpage. It is open source. And yeah, develop your own unique ideas and solutions. Yeah, that is all I have. Thank you.